In this lesson, we'll take a look at how to generate classification trees and then apply ROC to be able to select the cutoff probability. So once again, we start library caret because we're going to do partitioning, library rpart, library rpart.plot, both of these to use the rpart function to build the tree and to plot the tree. And we are using the library ROCR to generate the ROC chart. Okay, so once again, we are doing the same old thing, reading the data, same data set, Boston housing classification, and we are setting the factor levels. Once again, ignore it for now, it's not important. And then we say set.seed 2015 for replicability, and then we create the two partitions. Nothing different here, it's just like before. Okay, so now once again, we are building the tree. So this time just for, we are building the exact same tree, min bucket equals 10. So this is going to build the same tree that was built earlier. And we're printing the tree. Of course, we're going to get the same result as what we got earlier. So we've built the tree. Now we want to generate the ROC chart. Okay, so remember earlier when we used the predict function, we just asked the system to make a prediction based on the default cutoff probability of 0.5. Okay, this time what we are saying is no, you give me the probabilities, I will use the probabilities and then examine the ROC chart and decide on what is going to be my cutoff probability. So that's why we are using type equals prob here. Earlier we used type equals class. This time we are saying generate for me the probabilities and store the resultant probabilities in this variable called pred.probs. Pred.probs would look something like this. It's going to give you the probabilities for both the classes. Okay, so it's going to say for the first case in the training partition, the probability of it being high is 0.991, the probability of it being low is 0.0087. Okay, they should all add up to 1. Because of rounding, they may not be adding up exactly to 1. Okay, so that's what we are seeing here. Of course, if we assume that our positive class is high, okay, then we want to just take that. So what we want to do is to add the probability to the training partition. So I'm saying train $prob high. I'm just taking this and adding it as a column in the training partition. And I'm saying is pred.probs, which is this object, comma, give me the first column. Okay, all the rows, but only the first column. So these probabilities alone, because this is our positive class, assuming this is our positive class, these probabilities alone will now get into the training partition. Okay, so now once we have the probabilities, we of course can use these probabilities to plot an ROC chart and then select the cutoff probability. That's what we are going to do now. Okay, so we are now saying, of course, the library, we've already loaded the package ROCR. Now we are using the first function prediction. And if you recall from our earlier examples, the first argument to the prediction function is the column that contains the probabilities of the positive class, probabilities for the positive class. So that's our train $prob high. The second contains the actual classifications for the cases, which is trained $medv underscore cat. Okay, but important point is, because we've got the actual class, we've got two values, low and high, we need to tell the system that our positive class is high. Okay, so that it can interpret these probabilities as the probabilities for the high class and not the low class. Okay, so to do that, we need to indicate the label ordering low and high, right? If we didn't do that, alphabetically, it would have treated low as the positive class, because alphabetically H, I, J, K, L, L comes after H, so L becomes greater, and therefore this would be considered the greater value, and therefore low would have got treated as the positive class. We don't want that, so we are explicitly indicating that high is our positive class. Okay, so in prediction we have done the usual, and the next is to generate the performance object, which is performance pred, which is this object, whatever is the variable that contains our prediction, and TPR, FPR, true positive rate, false positive rate. Once you have that, you can plot it. Okay, and then draw the 45-degree line and you get this. Okay, so that's our ROC chart. Of course, it looks artificially too good to be true. In the real world, you will not get ROC charts like this. Okay, but we're just using this to illustrate. So presumably, I would like to have this cutoff here, right? Because up to this point, there's a very steep increase in true positives with almost no gathering of false positives, which is good. Beyond that, the true positives become very difficult to find. And so maybe we will choose this as the cutoff. Okay, so to find the probability associated with this point, right, because this point is only telling us that the true positive is greater than 0.8 and the false positive is very small. Okay, that's all it tells us, but we don't know the cutoff that generates this point. Okay, we want that true input. So in order to do that, we want to generate the actual points, the individual points, true positive, false positive, and the cutoff. Okay, so to do that, we use this prob.cuts, and again, this code is there. You can just blindly type it in really, and then we look at that, right? So clearly, it looks like this point is this one really, point number 2, right? Because this is the first point, 0, 0, and that's the second point. It looks like this, in which we get 85%, it looks roughly here, 85% of true positive and less than 1% of false positive. And the cutoff can be really high. We can say cutoff is 0.991. Okay, so let's say that in order to get this point, which is 85%, 86% true positive and less than 1% false positive, suppose we want that, then we can use a cutoff of 0.99. Okay, that seems like a very high cutoff. And maybe we say, okay, let's go ahead and get these true positives as well and land up at this point. Okay, so that would take us really to a 90% true positive and 7% false positive. Okay, so we're saying, okay, we'll take 7% false positive to get this. Now, this is a judgment call. Whether you want to stay at this or this is a matter of your business, right? So we need to understand the business and say, okay, well, what is the meaning of getting a false positive? How badly does it affect us? Okay, so let's assume that we will use this point, and therefore we'll use this as our cutoff, 0.42. And we can now go ahead, use the cutoff, and generate the actual predictions based on the cutoff. Okay, so on the test partition, we are going to generate the predictions. So we use the training partition to determine the cutoff probability. And now we are just saying for the test partition, once again, first thing we need to do, of course, is to generate the probabilities. So we again say pred.probs is predict bh.tree. Use that model, use the test partition now, and type is probabilities, right? So you get these probabilities once again. Okay, these are different probabilities than what we got earlier. Those were for training, these are for test. Okay, so now that we have the probabilities, we can apply the cutoff. Once again, we are going to add just the first column because we want only the positive class. So we add the first column as a new column here, prob high on the test partition, and then we can always say if else, right? So the model prediction would be if else test $prob high is less than cutoff, then it's going to be low. Otherwise, it's going to be high, because if it's cutoff equal to the cutoff or greater, then we'll classify it as belonging to the positive class, which is high. Okay, so once you do that, you can always generate the error matrix, because the actual value is contained in this column. The predicted value is now contained in this new column that we created, model pred, and we can generate the error matrix. Looks like this. So let's try and compare it with what we got in the earlier lecture when we used the default cutoff. So here with the designer cutoff, so-called, that we generated from the ROC chart, we got a performance on the positive class of 52.5, 57, whereas without that, with the default, we had got 49.8. Okay, so assuming that this is a positive class and that we would like a certain performance in the positive class and are willing to take a little bit of a hit on the negative class, right? So then this is what we're getting. Okay, so this is what we got earlier. Now we deteriorated our performance on the negative class by a little bit, but we got a good improvement in the positive class, right? So we reduced the 3 false negatives and increased the number of true positives. Whereas we got, of course, in the process a little bit extra of false positives. Okay, so that's really what the ROC chart helps us to do. It helps us to make a distinction or determination of what trade-off we are actually willing to make.